Hello everyone, I am Jose Lucas and I am here to explain about pipelining. Uh, as you will see, how to understand the concept first of all is very important. So answering to WH questions, which are very basic concept in English, is very useful to understand the concept. So what is pipelining, why is pipelining is needed, and how does pipelining work? And when pipelining does fail or slow down, where is pipelining used in CPU and who handles this detection? And let's understand each concept. So what is pipelining? Pipelining is a process of arranging hardware elements of CPU such as its overall performance is increased. Simultaneously, execution of more than one instruction takes place in a pipeline processor. In pipelining, multiple instructions are overlapped in execution. You can see overlapped is highlighted in green because it is a keyword in this pipelining concept. So accepting new input before previously accepted input appears as an output as to the other end. So this is the design of the pipeline. Pipelining has two ends, the input end and the output end. Between the input and the output, it has multiple pipes which are interconnected, satisfying the functionality. These pipes are called segments. Between the buffer are used to store the intermediate result. This buffer is also called as pipeline. See, in this diagram, we have this area which is lightly in colored. It is known as interface register, so that it can store the output of the previous segment or the state segment which produces the output for the given input. So it is stored till it gets out of the last segment. So why pipelining is used? Pipelining is used because mainly to increase the performance of the CPU. It addresses the inefficiency of the non-pipeline system where most hardware components sit idle while a single instruction occupies on one specific part of the processor. Why pipelining? Because it increased the throughput of the CPU. By overlapping the execution of multiple instructions, the CPU can complete one instruction per clock cycle in an ideal scenario, even if single instruction takes several cycles to finish. Since CPU is a multitasking, we feel it is a speed, but it actually executes only in one instruction per second. So it increases the efficient resource utilization. Different parts of CPU like ALU and memory interface registers work on different instructions at the same time. So it increases the higher clock speed also to execute the single instruction. Pipelining breaks down a complex task into the smaller, simpler stages because each stage does less work. The electrical signals have less distance to travel, allowing the processor to run at a higher clock frequency. So these are the pipeline stages. The first stage is instruction fetching, second stage instruction decode, third stage execution, fourth stage if the execution does require a memory, it has a memory stage. If not, it gives a write back. When does this pipeline fail? When it has some hazards, this pipeline fails. We shall take the example of a admission in a college or some school. When document verification is over in the first step, you have the first person going to the next process nothing but as payment. So during the second process of the first person growing, that is payment, the second person will be at the process of document verification. So when if the hazards like If the process verification does takes more time, it causes an hazard to that process. Hence, pipelining also has some hazards when it is in process. So these hazards are structural hazards, data hazards, and control hazards. When two or more pipelining stages need the same hardware resource at the same time, it is known as structural hazard. When instruction depends on the result of the previous instruction that has not finished is called data hazard. And when a branch or a jump instruction changes a program overflow is called control hazards. Structural hazard is also called a resource conflict, where occurs when two or more instructions require access to the same hardware resource simultaneously, then the hardware cannot support required parallel access. Like, if we see in this cycle, we see the instruction 4 is requiring the memory at clock cycle 4, and instruction 4 is requiring clock cycle at 5, and instruction 4 at clock 6 is requiring memory, and both in three all three clock cycles. So if this memory is not accepted by the CPU, then it is a structural hazard. Let's move to data hazard. Data hazard occurs when instructions exhibit the data independencies, such as one instruction depends on the result of a previous instruction that is not yet completed. So if the execution of the second instruction is not yet completed, but it's wait for the execution of the first instruction, then it is called as data hazards. Control hazard is also known as branch hazard, arises when the flow of execution is altered by a branch or a jump instruction, since fetching the next instruction depends on the outcome of a branch. The pipeline may fetch wrong instruction before knowing the actual branch direction. When each branch when each stage uh, delays the output, then the branch the branch accepting the output will be delayed, hence it leads to wrong output. So where is pipelining used in CPU? Mainly while execution of the instruction, where different parts of instruction are processed simultaneously in the stages. So who handles the detection handle is by dedicated to control hardware inside CPU. So this detection is located in control unit or pipeline control logic, and continuously monitors. So when interrupts occur in the CPU, this this continuously monitors. When the CPU is idle, it continuously monitors the interrupts occurring. So it is known as pooling. Source and the destination registers. Source and the destination registers must be uh, crystal and clear, so that the input and the output must will should be received as per the logic cycle. Pipeline stage status. Always it ensures the pipeline stage status should be uh, in the must be clear to execute the next stage. So instruction level parallelism refers to the capability of a processor to execute multiple instructions at the same time. Instead of running each instruction strictly one after the other, LP uses hardware and compiler techniques to overlap instruction execution wherever dependencies allow. Identifiers independent instructions and runs them parallelly. Instruction level parallelism as it refers to the capability of the processor. It allows to execute multiple instructions at the same time, and it is known as overlapping the instruction. So works within the single processor, not across multiple cores. It has only a single processor where it can run multiple instruction at the same time. So basis of modern CPUs with organized instruction scheduling. We have job scheduling, instruction scheduling, and all different types of instruction scheduling in the CPU. So using those algorithms, the overlapping of the instructions is occurred in the instruction level parallelism. So let's see some advantages and disadvantages. Advantages are improved performance of the CPU. It allows the uh, great performance of the processor by allowing multiple instructions to be executed simultaneously out of order. This can lead a faster program execution in a better system throughput. it, this point just says that the performance of the CPU is increased, and nothing but as the throughput, it improves the performance of the throughput. Efficient resource utilization. ILP can help efficiently utilize processor resource by allowing multiple instructions to be executed at the same time. This can help to reduce resource wastage and increase efficiency. When the execution of the multiple instruction takes place at the same time, it reduces the wastage and increase the efficiency. Reduced instruction dependencies. ILP can reduce the number of instruction dependencies, which can limit the amount of instruction level parallelism that can be exploited. This can help to improve performance and reduce bottlenecks. This bullet point explains that why ILP is used, because when there are multiple instructions executing at the same time, uh, it it improves the performance and reduce the hazards. So increased throughput. It can increase the overall throughput processes by allowing multiple instructions to be executed simultaneously out of order. This can help to improve the performance of the multi-threaded applications or other parallel processing tasks. ILP increases the overall throughput by the processors by allowing the multiple instructions to be executed at the simultaneously. This this performance is used to execute the multi-threaded applications and parallel processing altogether. So the disadvantages coming: increased complexity. Implementing ILP can be complex and requires additional hardware resource, which can increase the complexity of the cost of processor. When ILP is ILP comes to an occurrence, it requires an additional hardware resource, where it can increase the complexity and the cost of processors. Instruction overhead. ILP can introduce additional instruction overhead, which can slow down the execution of some instruction and reduce the performance. When the execution of the multiple instruction at the same time, if the instruction requires an hardware, it takes an extra time or extra clock cycle to execute instruction, and thus it reduces its performance. Data dependency can limit the amount of instruction level parallelism that can be exploited. This can lead to lower performance and reduce the throughput. Data dependency is the amount of instruction level parallelism that can be exploited. Reduced energy efficiency. ILP can reduce the energy efficiency of the processor by requiring additional hardware resource and increasing the instruction overhead. This can increase the power consumption and result in higher energy cost. This point explains about the how the electricity or the energy is used by the hardware devices to execute the ILP. So let's understand through one aptitude question. as you see, why we need to understand this, because instruction pipelining is similar to work in time problem, where multiple workers perform different parts of job simultaneously, reducing the completion time. So thank you. These resources are extracted from the Geek for Geeks website, hence it will be given in the description. You can check it.